The history of human civilization has its origins in the prehistoric cave paintings. The apprehension and worship of animals and ferocious forces of nature find expression in these sketches. Thus, the canvas of history was painted in assorted combinations of colors. Then, visuals and symbols metamorphosed into power of vision with a convincing touch of colors and shades. Watchful eyes perceived the visual diversity, and the brain defined and distinguished these visual extravaganza. Yes, then man became the master of vision and its diversity. There was touch of light upon everything that can be seen. It was a fusion of colors and tones. Refraction is just one among the properties of light. Light, when it travels from a medium to another medium of different density, takes a deviation on its path. Objects dipped in water appear disfigured as the path of light gets deviated when it travels from air to water. Light behaves the same way inside a glass prism. When it comes out through the corners of a prism, a band of color is formed. This is the composite color of light, or the spectrum of light.
സ്പെക്ട്രത്തിനെ പറ്റി പഠിക്കുന്ന സമയത്ത് രണ്ട് മൂന്ന് കാര്യങ്ങൾ നമ്മൾ ശ്രദ്ധിച്ചിരിക്കുന്നു. ഒന്ന്, നമ്മൾ തിരഞ്ഞെടുക്കുന്ന സോഴ്സ്. നമ്മൾ ഉദ്ദേശിക്കുന്ന നിറങ്ങൾ എല്ലാം ഉൽപ്പാദിപ്പിക്കുന്ന ഒരു സോഴ്സായിരിക്കണം നമ്മൾ ആദ്യം തിരഞ്ഞെടുക്കേണ്ടത്. അതിന് സാധാരണ ലാബിൽ ഉപയോഗിക്കുന്നത് മെർക്കുറി ലാമ്പാണ്. കാരണം സൂര്യപ്രകാശനോട് ഏറ്റവും അടുത്ത പ്രകാശ നിറങ്ങളുള്ള ലൈറ്റ് തരുന്നത് മെർക്കുറി ലാമ്പായതുകൊണ്ട് അതുമാണ് ആദ്യം വേണ്ടത്. രണ്ട്, നമ്മൾ തിരഞ്ഞെടുക്കുന്ന പ്രിസം. ഇതാണ് പ്രിസം. ഇതിന് ബേസ് എന്ന് പറയും പരുവരുത്ത പ്രതലമാണ്. അതിലൂടെ റിഫ്രാക്ഷൻ ഒന്നും നടക്കില്ല. പിന്നെ ഈ സൈഡിനെ ഫേസ്, ഇത് അടുത്ത ഫേസ്, ഇത് മുകൾ ഭാഗം, താഴെ ഭാഗം, ഇങ്ങനെ പ്രിസം കൈകാര്യം ചെയ്യാവും. അത് കഴിഞ്ഞ് പ്രിസം സ്പെക്ട്രോമീറ്റർ വെച്ചതിന് ശേഷം സ്ക്രൂ ഉപയോഗിച്ച് ഉറപ്പിക്കുക. അത് കഴിഞ്ഞ് സ്പെക്ട്രോമീറ്റർ അഡ്ജസ്റ്റ്മെൻ്റ് എല്ലാം കഴിഞ്ഞ് സ്പെക്ട്രം ഫോളോ ചെയ്യുക. അതായത് എനിക്ക് സ്പെക്ട്രം കിട്ടിക്കഴിഞ്ഞു. ഭംഗിയുള്ള 7 നിറങ്ങൾ 7 വരകളെപ്പോലെ അവിടെ കാണുക.
Spectrum is the distinctive distribution of white light into composite colors. It was Sir Isaac Newton who first discovered that the colors of the rainbow come out of a prism when sunlight is passed through it. This spectrum of sunlight is a consecutive series of colors of varied wavelengths. It is visible in 7 major sections. Violet, which has a maximum deviation, appears at one end, while red, having minimum deviation, appears at the other. The other 5 colors array in between red and violet according to their deviation. The term with gyur denoting the first alphabet of violet, indigo, blue, green, yellow, orange and red signifies the position of color in the spectrum. Both candlelight and electric light have spectrum, but with low color intensities of yellow and blue than in sunlight. When light passes through 2 prisms mounted on opposite bases, the spectrum of light coming out of the first prism turns into white light when it travels through the second prism. We can see colors in the fringes of white light. A beam of light consists of many rays. Each ray, when it enters the first prism, gets dispersed into composite colors and enters the second prism. Here, refraction takes place and it comes out as a white beam. Each ray superimposes to give white light with red and violet fringes. This phenomenon of superimposing does not occur on the fringes, and red and violet will be faintly visible on either side. Colors deviate differently based on variations in their wavelengths. This difference causes dispersion of light. When a composite light splits into its constituent colors, it is dispersion of light. The splitting of colors due to dispersion can be seen here in the corners of a fish tank. When sunlight is reflected, using a mirror kept under water, constituent colors are visible. When it stops raining, water droplets are seen slowly dripping down the leaves and tree trunks. Dispersion takes place in these droplets and an array of colors are seen. During rainy days, rainbows are visible against the sun either in the morning or in the evening. When sunlight falls on countless raindrops in the atmosphere, simultaneously colors are split due to dispersion and appear as a rainbow on the horizon. Inside these water droplets, 2 refractions and 1 internal reflection take place to form constituent colors which appear as a rainbow in the atmosphere. Only one of these colors can be seen at a time. Red-colored rays with low deviation create a particular angle along the line of sight between the viewer and the rainbow, and all other water droplets which appear as red will also create the same angle along the line of sight. Meanwhile, violet and other colors which deviate more will impart different angles to the viewer in the same way. The arc shape of the rainbow is due to this reason. Due to the refractions and internal reflections inside each droplet, colors get separated from sunlight and a secondary rainbow, which is foggy, is seen just above the primary one, where the colors are in the reverse order. From a distance of more than 2.8 kilometers above the Earth, the rainbow seems like a perfect ring of colors. This is Newton's color disk. When rotated slowly, it shows a mixture of the 7 colors. When rotated fast, the colors are seen almost together because of persistence of vision, and you see white. Persistence of vision is a property of the eye. Here is yet another example to explain this property. When an object is withdrawn from sight, the perception of seeing it will remain in our eyes for the next 1/16th of a second. A wheel drum has miniature windows at proportionate intervals. Inside this drum, singular pictures of continuous movement of an object are arranged. While watching these pictures through the window of the rotating drum, the object seems set in motion. The concept of motion pictures, that is cinema, was evolved from the theory of persistence of vision.
Why, you... Oh! Get on now! Oh, he bit my finger! There!
The ring of fire, which appears when lighted crackers are rotated at high speed, is also due to the persistence of vision. When we think about colors, the first thing that comes into our mind is an artist and his studio. They give life to painting through colors, imaginatively and aesthetically. Red, blue, and yellow are the primary color pigments. Yellow and blue combine to give green. Yellow and red mix up to give orange. Red and blue on combination give violet. On further mixing, a vast world of colors can be created. The primary colors of light are red, green, and blue, and are represented by their first alphabets R, G, B. Red and green superimpose to form yellow. Likewise, green and blue forms cyan, and blue and red overlap, giving magenta. These are the secondary colors of light. Red is commonly used to signal danger and caution. Red color is subject to low scattering, so it travels greater distances through air to reach our eyes. Traffic signals are of three colors. Green color allows smooth traffic, and red signal checks it, while the orange color in between them signifies caution before switching over from one signal to another. During rainy, foggy and dusty climates, yellow headlamps are commonly used instead of regular headlamps. Yellow light has low scattering due to greater wavelength. When white light falls on water droplets or dust particles, composite colors, which have low wavelengths, are subject to heavy scattering. If yellow lights are used as street lamps, it will not get reflected from water droplets and dust particles, but will directly illuminate the objects. Of course, red has more wavelength than yellow and so has a low scattering, but it will not help to illuminate objects. Moreover, it being an authorized signal of danger, red lights are not used as headlights of vehicles or street lights. Many objects that we come across in day-to-day life seem translucent. They are semi-permeable to light and display some interesting sights. The translucent nature of some flowers and foliage are really amazing. Sometimes, objects which are opaque turn transparent while reacting with some medium. If oil is applied on a white paper, it becomes transparent. The wax of a candlestick, when it melts due to the heat of the flame, changes from its original opaque condition to a transparent condition for a short while. This is due to the reaction of wax with fire. Cinema is the image that appears on screen when light is passed through transparent celluloid film. Slides of this category display some beautiful sights by separating colors and shadows. Transparent glass papers and cellophane slabs permit the entry of its own color only. When white light passes through any transparent plane, only the color of the transparent plane is carried through. All other colors of the spectrum are absorbed. Here, lines are drawn on a white paper, 3 in red, 2 in green and the other in blue. When they are seen through a transparent red sheet, the white paper becomes red and the red lines are invisible. Green and blue turn dark and only 3 lines become visible. Through green, the paper turns to green and the green lines are invisible. Red and blue become dark and 4 lines are visible. And through blue, on a paper which now attains blue color, blue lines are invisible. red and green lines appear as 5 dark lines. Now through a yellow sheet, the paper attains yellow color. 3 red lines and 2 green lines are now visible in their original colors. This is because the yellow medium allows red and green colors as they are its primary components. The blue line will remain as dark because yellow does not allow blue color to pass through. There are a number of objects around us, both alive and inactive. They have individual color diversity, but they won't be able to excel without light. Different objects attain different colors when they reflect their own color and absorb all other colors of the spectrum of sunlight. Red, yellow, and blue colored blossoms reflect their own colors of the spectrum and absorb all the other colors. Green foliage is beautiful as it reflects the green color and absorbs all other colors. These roses are kept in a bright sunlit room. See the changes taking place in the color of these flowers as monochromatic lights are introduced into the room. There are invisible regions in the spectrum on either side of the visible region, infrared beyond red and ultraviolet beyond violet. Ultraviolet radiation can be detected through its photochemical reaction with a photographic paper coated with silver nitrate. Science has proved that the honeybee can see ultraviolet rays. It is quite common in villages that mothers expose their children to early sunlight, believing that this will make them grow healthy and active. The ultraviolet rays present in sunlight helps to create vitamin D on reaction with the skin. This is the science behind their elementary knowledge. But extensive exposure to ultraviolet rays will darken the complexion and is injurious to health. It may also reduce eyesight. Only a low percentage of ultraviolet rays reach the Earth after the radiation through the air. Fluorescents are objects which can glow by themselves on receiving ultraviolet rays. They receive ultraviolet rays with low wavelength and emit visible light with high wavelength. Hoardings painted in fluorescent colors offer more visibility even in low light conditions. Many washing powders offer glowing whiteness, but not many of us know that the washing powder contains fluorescence. This sticks to the cloth, which glows when exposed to ultraviolet rays. Infrared region lies just above the visible region of light and next to the red color. When a thermometer is placed in this region, the temperature reading can be observed. This proves the presence of infrared. A red-hot iron rod emits infrared rays. The remote control of electronic goods works using infrared rays. It is subject to low scattering as it has higher wavelength than visible light. Infrared photography is different from ordinary photography. Infrared photography is used to photograph distant objects and also in dusty and foggy climate. The reason is that infrared has high wavelength and so a low scattering in dusty atmosphere. Every object has its own body temperature. Photographs of the objects can be taken by sensing the variation in the body temperature using infrared photography. Light rays scatter in an orderless manner to different sides while they travel through dusty air, fog, and water. This property of light is called scattering of light. Scattering of light can be observed when light is passed through milky water or through rough glass. The scattering rate of violet is 16 times higher than that of red when sunlight travels through the air. Light travels a great distance to reach the Earth. The shorter waves of the light spectrum get scattered on hitting the dusty particles and air molecules. Violet, indigo, and blue with low wavelengths scatter to form a region where blue color dominates. This imparts blue color to the sky. Atmospheric air is absent on the moon, and scattering does not take place there. So the lunar sky is dark always. It is due to scattering of short waves in the spectrum that the sea and deep lagoons are blue in color. The golden skies at sunrise and sunset are everyday marvels. At noon, as the sun is perpendicular to the earth, light travels a shorter distance to reach the earth. But during sunset and sunrise, light travels longer distances. Only colors with longer wavelengths reach the earth after scattering. But red, orange, and yellow are dominant since they have greater wavelength and low scattering. So the sun and horizon appear as combinations of yellow, orange, and red. This is the time when you can encounter the sun face to face. This colorful visual fiesta has been enjoyed by millions of people of different ages. And these warm colors soothe the minds of the viewers. This is yet another morning, the rebirth of light and colors, to experiment and experience more about a world of visual diversity. To a layman, colors are merely existence of light. To an artist, it is a combination that gives birth to his imagination. To a physiologist, colors are reflexes of optic centers of the brain. To a psychiatrist, it is the emotional expression of the mind. But to a scientist, colors are nothing but the functions of an energy source that emits light. Anyhow, the dimensions of color set boundless platforms to discuss all these viewpoints and make this universe a wonderful place for us to live in. Let the colors remain. Let them grace our visions forever.